All right, now welcome to chapter 6.1. We're going to cover a few things on this one. Eventually we're going to get to identities in this chapter. Also, something that you would probably be useful to have throughout this chapter is a copy of the formula sheet. And just a reminder, you can use this for any of your quizzes and tests, and the formula sheet that you get on the exam will look probably exactly like the one you have here in class. So getting started, I'd like to talk about the difference between what is an equation and what is an identity. So, well, we've done equations for a long time. So if I say something like 2x plus 1 is equal to 5, and I say, can you solve this? Really what I'm asking you to find out is what value for x would make that a true statement. So when is this true? When, in this case, I guess would be when x is equal to 2. So when we're doing a trig kind of version of that, and if I say sine of theta is equal to half, to solve for that is to tell me when is that a true statement. And so we have two answers in this case. We have pi over 6 and 5 pi over 6 if we're going to only do between 0 and 2 pi. Well, an identity looks a little different. If I said, well, x plus x is equal to 2x, that would be an identity because it's true for all values of x. It doesn't matter what x could be. It's not just x equals 2, x could be any value. Sometimes identities will have a few restrictions to it. So for example, if I say x over x is equal to 1, you might say, hey, that works for any value of x because anything divided by itself is equal to 1, except there is one non-permissible value, and that you cannot say x would be equal to 0. So I have to add that little x can't be equal to 0 because I can't divide by 0. So looking at an identity, here's an example of an identity. Tan of x is equal to sine of x over cos of x. Here's a few more identities. And these are the basic ones that we've taken before. Tan is equal to sine over cos. The reciprocal of tan is cotan. And just what happens is the numerator and the denominator get reversed. Sometimes it's hard to remember the cosecant and secant. So cosecant is the reciprocal of sine, and secant is the reciprocal of cos. The way I remember that is that the c and the s are opposite here. So if you have got sine x, the reciprocal, this starts with an s, the reciprocal starts with a c, so it always switches. So that's just a few ones to get started with. The bottom of the page says non-permissible values is any value that results in a denominator equal to 0. That's just like in my example over here. We can't have a 0 in the denominator. So sometimes you might be asked to find these non-permissible values. So what about for cotan x is equal to 1 over tan of x? Well, really the first step in doing this, we want to kind of expand it. So what is the cotan of x? Cotan is equal to, well, if we forget, we can just look over here, and cotan is equal to cos over sine. So I'll rewrite that part. I'll say cos of x over the sine of x is equal to 1 over, and then I'm also going to expand tan. So tan is equal to the sine of x over the cos of x. So now I'm got to check to find out if there is a denominator equal to 0. So I'm going to look for all the denominators. Here is a denominator. Here is a denominator. So I want to look for those specific times here. So I'm going to say, well, if sine x is equal to 0, when would that happen? Now if I draw a little unit circle here, so sine is the y value. That would happen here and here. So that would happen when x is equal to 0 and x is equal to pi. So that would be that example. And over here, cos of x, when is the cos of x equal to 0? When is that denominator equal to 0? Well, for cos is the x value, so I guess that would be here and here. So I would say x is equal to pi over 2 and 3 pi over 2. So my final answer here, if I put them all together, I would say 0, pi over 2, and 3 pi over 2 would be my answers, the non-permissible values. And you could say the non-permissible values are It'd be okay to write it this way too, say x cannot be equal to those things, because we're talking about things that x cannot be. So it's up to you about whether you want to write an equal sign when you list them, or you can put a not equal sign. Let's try the other side here. Cotan. So just for space's sake, I'll go over here. Cotan is equal to cos of x over the sine of x. All over. So tan of x is equal to sine of x over cos of x minus 1 times the sine of x. Okay, so now let's think about all the times when we have a denominator. So here we have this sine of x is a denominator, and we kind of know this already because we've done the work. When sine of x is equal to 0, we've got this x cannot be equal to 0 or pi. So I'm just going to put that part over here. I'll just keep track. Because of, maybe I'll write it. Because of this one, I'll say x cannot be equal to 0 or pi. And then we've got this one, this cos, and we sort of did that one already, right? Over here we said when cos is equal to 0, it's pi over 2 and 3 pi over 2. So I'll write that out. I'll say here, x cannot be equal to pi over 2 or 3 pi over 2. Looking at the denominator as a whole, and maybe I'll just go back to looking at it over here before I expanded it, this denominator will happen when either this is 0, which we've already accounted for, or when tan x minus 1 is equal to 0. So the last one we're going to look at is say, well, what about tan x minus 1 equals to 0? Here's our third situation. We had one here, we had a second one here, here's our third one. When is tan x minus 1 equal to 0? Well, if I solve for tan of x is equal to 1. When is tan of x equal to 0? Or when is the sine of x over the cos of x equal to 1? When are they equal? So looking at my unit circle here, it's going to be this value here when both are equal to root 2 over 2, and that's at pi over 4. And the other value is over here at, what would that be, 5 pi over 4. So I'll say x cannot be equal to pi over 4 and 5 pi over 4. So we have all these different answers. And I guess to be good, we should probably list them all in one spot at the very end. So it takes a little bit of effort to sort of hunt through and find all the different possibilities. So just for a quick review here, here was an example of a denominator. Here was an example of a denominator, and we looked at this entire denominator where either sine of x was equal to 0, and we did that already, or tan x minus 1 was equal to 0. Okay, so on to the next page. We're going to show you on the top of this page where some of these formulas come from. So we're going to show you where these ones come from. So the first part is this Pythagorean identities. So in the unit circle, here I'll just draw a circle. In the unit circle, if we have an angle, here's an angle. So if we have an angle here, and I'll draw the triangle even bigger because it's easier. The x value here is the cos of the angle, and the y value is the sine of the angle, and the radius in the unit circle is 1. And so this reminds us of the fact that it's a right triangle, and because it's a right triangle, that's where this comes from. The sine squared plus cos squared is equal to 1. So that is in our formula sheet. And where do the other ones come from? Well, if I divide everything by cos squared theta, I would get number 2 and number 3. And then we can rearrange them. So these are what's in your formula sheet. Don't worry, you do not have to go through these steps and show how they were derived. They're given on your formula sheet, and every once in a while you just might go looking for them. I would have to say that this version down here and this version down here of sine squared plus cos squared equals 1 when you solve for cos squared theta or when you solve for sine squared theta. These are really helpful for later on in this. And I'm even going to show you, because maybe you'll remember it, that the reason why they're nice is in this, where should I write, cos squared. If you had cos squared theta, you could rewrite that as 1 minus sine squared theta. And then you could rewrite that and you could factor this using the difference of squares. This would be the same thing as 1 plus sine theta times 1 minus sine theta. And so just to think about, if you would multiply these two together, you would get this. So this is factoring by a difference of squares, and you're going to find that's very helpful if you started with a cos squared theta and then turning it into 1 plus sine theta times 1 minus sine theta. I'll just read this note here. It says these identities are only true when the trig functions are squared. So it's not sine theta plus cos theta equals 1. It's sine squared theta plus cos squared theta equals 1. All right, on to our example number 2. It says to verify that the equation is true. Okay, so let me just check our formula sheet. If you look on the back side of the formula, oh, it's not there. There are some definitions of words, and there is one for verify. So to verify is to plug in the numbers and see if it's true. So for example, if I said, what was our example? 2x plus 1 is equal to 5. And if I said verify if x is equal to 2, what you would do is you'd say, oh, okay, I'll plug in a 2 for, I'll plug this in right here, plus 1 equal 5, and I'm going to check, is it true? 4 plus 1 is equal to 5. 5 equals 5. Check, it works. So that's how verify works. So let's try it with this example. And I'll plug in my 60 degrees. I'm going to say, okay, so the secant, I'm going to check, is the secant of 60 degrees divided by the tan of 60 degrees plus the cotan of 60 degrees in fact equal to the sine of 60 degrees. Where's 60 degrees on a unit circle? 60 degrees is up there, right? And so let's just think about our functions here. The sine of 60 degrees is going to be root 3 over 2. The cos of 60 degrees is going to be equal to a half. The secant, which is the reciprocal here, the secant is the reciprocal of cos, so the reciprocal of a half is equal to 2. Which some other ones we need to know. The tan of 60 degrees is going to be equal to, well, it's root 3 over 2. It's the sine over the cos, 1 over 2. We can multiply the top and the bottom by 2, or we can say root 3 over 2 times 2 over 1, and then these cross out. So the tan of 60 degrees is going to be equal to root 3. The cotan of 60 degrees is going to be equal to, it's very similar here. Oh, I'm running out of room. Instead of root 3 over 2, it's the other way around. So root 3 over 2, 1 over 2 over root 3 over 2. So I can write it as 1 over root 3. Or it's just the reciprocal of that, right? So let's go in here and substitute them in. So the secant of 60 degrees was root 3 over 2, all over the tan of 60 degrees, which is root 3, plus the cotan of 60 degrees, which was 1 over root 3. And we're going to see if that is equal to the sine of 60 degrees, which is root 3 over 2. Oh, I think I made a mistake. I think this secant was supposed to be equal to 2, so I'll put this 2 up here. There we go. Okay, so looks like some difficult fraction work. So my first goal here would be to combine these two terms. So if I'm going to add together root 3 plus 1 over root 3, I'll have to put them over a common denominator. So I'm going to say root 3 times root 3 over 3, or root 3 over root 3, plus 1 over root 3. So what I've done here is, see if I can get rid of that, I have multiplied this first term in the fraction by a value that's 1, so I haven't changed it. So what do I get? Root 3 times root 3 is equal to 3. So this will be my new denominator. Kind of running out of room here a little bit. So my next step will be, and that still is equal to root 3 over 2 equals root 3 over 2. So now I'll get 2 all over 3 plus 1 is 4 over root 3 equals root 3 over 2. Now, how do I fix the left-hand side? I got a complex fraction. 2 divided by that is the same thing as 2 multiplied by the reciprocal, which is root 3 over 4 is equal to root 3 over 2. And you can see now I'm going to be simplifying this. This is a 2 and this is a 1. So I get that this does work. Root 3 over 2 is equal to root 3 over 2. So that's how you would verify. Verify is about plugging in the numbers and then seeing if the math works. And I know the whole complex fractions can look a little bit difficult there. The next part says state the non-permissible values of the above identity over the interval. So let's go and first of all expand this. So secant is the same thing as 1 over cos of x all over tan is sine over cos plus cotan, which is cos of x over sine of x, is equal to the sine of x. So are there any non-permissible values? So notice I'm not thinking about this x equals 60 degrees. I'm thinking about all the different values of x. Are there any values of x I could not put in there because there would be a division by zero error? So here's a cos of x in the denominator. There's another cos of x in the denominator, so I'm not going to highlight it twice, and then there's this sine of x. So what I'm looking for is when is cos of x equal to 0 and when is sine of x equal to 0.